David Smith here with one more Flipped Classroom math video. 3 tips before we start. Remember, you can pause the video at any time to catch up with your notes. You can also turn on the caption down below and watch my words go by on your screen. Lastly, if you feel like you can do this, you can speed up the playback and get through the video a little bit faster. Today's lesson covers the inverse normal distribution. And the nice thing here is that the calculator work is very similar, so you're not going to need to learn new calculator tricks, but some of the critical thinking is a little bit more challenging. So let's jump right in. So first off, this is finding x or z when the probability is known. So you're going to be presented with a scenario where you're going to be told what the probability is, you're going to be told information about the distribution, and then you're going to have to find a given x value that they're after. So check this out. Here is my normal distribution curve, my standard normal, because my mu is 0 and my standard deviation is 1. So I've got a z. Now, this represents a situation, or might represent a situation, where let's say I make milk and my factory kicks out milk cartons. Now, I want to make sure that a very high percentage of my cartons have the correct weight. In fact, I'm only willing to allow 5% or less of my cartons to go out the door to be underweight, okay? So, in other words, I want 95% of my cartons to have a certain weight or more. So I know my probability, I know my value, I need to figure out what my z-score is. What is that weight that I need to reject so that over time I'll reject 5% of my milk cartons. Now we're going to come back to that problem in a minute, but first let's do a few examples. Actually, one more point. So here is our standard normal distribution with my standard deviations marked along the bottom, and I have this A. So this A is what we're going to try to find. So in that milk example, say I want to reject 5%, then this area under the curve needs to be 0.05, and I know that because I'm given that by the problem. I need to find where the A is on the horizontal axis that makes that area 0.05. Now, on the calculator, that's really easy, so let's get over to that. All right, here's a prompt you might get for one with a standard normal distribution. We also call that the standard normal curve. So check this out. What's the probability that our z is less than this value when our probability is 0.877? So I'm going to sketch the curve here, and we'll talk about what this means in the context of the curve. Okay, so here is the graph, and I've marked that little a value. Remember, that's our z-score, and we want the probability to be 0.877, that our z, which is all along here, gives us that it's in here, that z is less than a. So here's my area. Since my area is 0.877, I know that I'm past my mean, because because otherwise it'd be less than 0.5. So since this one is bigger than 0.5, I know I'm grabbing more than half of my curve. Since my z has to be less than the a that I'm trying to find, I'm going to the left. So check this out. Now you just put this in your calculator, and I want you to pause the video and go slowly through the menus. You know how to do this already on your calculator, and see if you notice the spot where you do the inverse normal distribution, because it's right there in front of you. It's just you make one slightly different choice when you put everything in the calculator. And remember, you're doing a standard normal with a 0 for your mu and a 1 for your standard deviation. All right, so you'll notice that there was just one option that's just below the normal distribution option when you're doing the calculation. It's just called the inverse normal distribution. So hopefully you found that, hopefully you got through it. And basically what you do there is you just put in your area where they give you a spot for that, and then you do your calculation. And so what I got for my a value is 1.16. So this is 1.16. So that means that you need to have your a value, your z, is 1.16 or less, and that gives you the probability that whatever happening in your situation is going to fall in this range. So here's another one, and I'm going to walk you through this one. Now we're trying to find our z values so that they create an area under the curve of 0.2, okay? Now, there's one tip here. We always want to be calculating the area to the left of our a value. With z being bigger than a, we need to re-articulate this problem. So we could rewrite it as pz less than or a is less than 0.8. Okay, so that allows us to set up our calculation in the correct way. So let me show you how that looks on the graph. So here's our curve. I put my a over here because I need my area under the curve to be 0.8, and I shaded the area under the curve because we want our z to be less than this value of a. I put that in my calculator and I get an a value of 0.842, so that's 0.842 there for my a. Now, don't worry if this seems real abstract. In a minute, we're going to make it more concrete. So now we're going to do this one. We want to find the a value for which z is going to be greater than that number and have the area under the curve be 0.55. Now, as you recall from the last screen, we really want to make it that we're looking to the left of the a value all the time we're doing these calculations. So we're going to rephrase this as z is less than a equaling 0.45. So we're just taking the opposite of that and we're changing our direction. So now pause the video and sketch the graph of that, shade the area that you're looking for, do the calculation, find your a, and come back. Okay, so I've shaded my graph. Notice how I am needing to be 0.45, so I know that that's to the left of my 0, which would be 0.5. So here's my area, 0.45. There's my a. Now, 0.45 is really close to 0.5, which is half. If it was 0.5, we'd end up with a 0 for a. So when I do this in my calculator, I got a equals minus 0.126, which is pretty darn close to 0. So this makes sense. This one's a little bit more tricky, so I'll walk you through it. So now I'm looking for a z that's going to be between the negative a and the positive a, and I want that z to create a probability of 0.42, or the area under that curve to be 0.42. So let's draw that curve first, take a look at it, and then do some analyzing. All right, so here's my curve. I've got my minus a and my a, and I'm trying to get a z between those two. So that's the shaded region that's 0.42. Now, a next step in this process is going to be to figure out the area of these two regions, the non-shaded regions. So go ahead, pause the video and do that for me. Okay, so to find these two areas, which end up being 0.29 each, I had to take a half of 1 minus 0.42. The whole thing is 1, 0.42 is here, so we take that away, and it's a half because these are symmetrical, so if whatever's left has to add with 0.42, then we have to divide that whatever's left in half to get 0.29, 0.29, 0.42. If you add all three of those up together, you're going to get 1. Okay, so this one's tricky. We're being asked to find a. So we're going to find a. Even though this is a range, you might be thinking, oh, well, we have to find this value and that value. But it's the same number. So you're just prompted to find a, and by implication, you have found negative a because that's just a negative. So check this out. We're being asked to calculate the a value that's going to give us all of this. Okay? And then by implication, the negative a value would be for here. So now we have a problem that you're familiar with. We've got an area of 0.42 plus 0.29, and we need to find the a value here that gives us that area. So go ahead, pause the video, do that calculation, and come back. All right, so that gives us an a of 0.553. So there you have that problem. All right, here's that real life problem I mentioned before. Milk cartons contain volumes that are normally distributed with a mean of 150 milliliters. And our standard deviation is 5 milliliters. I forgot to put that in, so I'm just giving you that down here. Given that we need to reject the bottom 5% of cartons for containing too little juice, let's pause for a minute. What that means is that the manufacturer is saying, I need to toss out the bottom 5% because I want my customers to feel safe that they're getting what they're paying for. So we need to find the minimum volume that would cause us to reject the bottom 5%. So that minimum volume is going to be the actual number when we weigh the milk cartons, and if they come in under that or they don't meet that minimum, we're going to put them back in the system. So here's an articulation of that. Random variable x, notice how we're not in z-land anymore because we have a standard deviation of 5 and a mean of 150. Random variable x, normal distribution, 150 for our mean. Our variance is 5 squared. Now, see if you can write the notation for the problem that we're being asked to solve. Okay, here's our problem. We want x to be greater than a, and we want the area under the curve to be 0.05. Okay, so now I want to go ahead and have you sketch the graph, plug it into your calculator, get an answer, and come back. Here's my graph, here's my A, here's my 0.05 area. I re-articulated it. Remember, we always want to be shooting to the left. So x is less than A equals 0.05. Now I'm going to use my calculator and do the calc. All right, so when I do that in the calculator, I get 141.78 milliliters. So basically, this manufacturer weighs every carton. As soon as something falls below this value, they take that carton and they recycle it back into the system, which means that they're rejecting the bottom 5% of volumes as a quality control. They're ensuring that even though they advertise 150, they're at least going to have 141.78 milliliters.
Now that you've watched the video, take a moment to write down any remaining questions so you can bring them to our next class. Also remember that you can watch the video again to remind yourself of what we did or deepen your understanding. If you enjoyed yourself, please click like or subscribe.